Now let's look at the concept of special angles, 30 degrees and 60 degrees. We also have 45 degrees, but we're considering these two first. Now, the reason for this is because sometimes you'll be given a question and required to leave your answer in a short form, or sometimes you're calculating, you don't have a calculator and you're looking for an angle, or you have angle 30 degrees or 60 degrees and you don't have a calculator and you do not have a four-figure table and you need to sort out your answer. So you can apply this knowledge of special angles. Now, to find these special angles, we're going to consider an equilateral triangle, meaning a triangle whose sides, straight sides, are equal. We have 2 centimeters, 2 centimeters. So the straight sides are equal. The angles too are equal: 60 degrees, 60 degrees, 60 degrees. Because the sum of these angles will give us 180 degrees. The sum of angles in a triangle give us 180 degrees. So if we have this and you decide to divide this into 2 equal halves, we're going to have something like this. We're going to reproduce something like this. Now here will be, you have divided this into 2, so this is 30, 30. Here will be 30 degrees. Here will be 30 degrees. So, and here will be 1, here will be 1, because we are dividing 2 by 2. So we don't know this. This will be this side, we don't know it. And here is 2, here will be 1. So don't forget, we say this is 60 degrees, this is 30 degrees. Now we apply the knowledge of Pythagoras theorem. In Pythagoras theorem, we said the square on the hypotenuse is equal to the sum of the squares on the other two sides. So we have 2 squared, the same thing as x squared plus 1 squared. As 2 squared equals to the square here plus the square of this one. So 2 squared is 4 equals x squared plus 1 squared is 1. Now we collect like terms. We can have our x squared equals 4 minus 1. So we'll have x squared is the same thing as 3. We take the square root of both sides. We have x equals root 3. So we'll now have the new shape like this. This is 30 degrees. This is 60 degrees. This is 2. This is root x for this one. Okay, sorry, root 3 rather for x. So we also have here as 1. So if you're asked to look for sine, don't forget we can use this acronym SOHCAHTOA. S for sine, C is for cosine, T is for tangent. So sine 30 degrees will be opposite over hypotenuse. So opposite is where the angle is facing. Opposite, this is the hypotenuse, the longest side. So opposite is 1 over hypotenuse, 2. If you're also looking for cos 30 degrees, cosine is adjacent over hypotenuse. So the adjacent here is this side. That's root 3 over adjacent over hypotenuse over 2. So root 3 over 2 is our cosine. I can also be asked to look for the tangent. Tan 30 degrees is the same thing as opposite over adjacent. So opposite, we are considering 30, opposite is 1 over adjacent. Adjacent is root 3. So this is tan 30. You can also be asked to look for sine 60 degrees. Sine 60 degrees, we are considering this is opposite. Don't forget, opposite over hypotenuse. Sine, opposite over hypotenuse. Opposite over hypotenuse. So root 3 over 2. You can also be asked to look for cos 60 degrees. When looking for cos 60 degrees, you have cos is adjacent over hypotenuse. So adjacent is 1, hypotenuse is 2. If you also ask to look for tan 60 degrees, you have it as tan is opposite adjacent. So the opposite is where the angle is facing. That's root 3 over the we have what is adjacent. Adjacent here is 1. So we can equally say that root 3 is the tan of 60 degrees. Now this is what we have for 30 degrees and 60 degrees. Now in the next video we are going to consider that of 45 degrees. Do not forget to like, to share and to subscribe. Thank you.